Hey, what's going on, folks? It's Mike here, and welcome back to the Deep Programming Language series. In today's lesson, we're going to be talking about template mixins. Now, if you've been paying attention and watching the last videos, because I know you're subscribed, you've likely been learning about templates, which are reusable chunks of code, and mixins, which are strings that we can effectively mix into our code. But if we combine these two powerful ideas, the idea of having a template that we can parameterize and a mixin that at compile time we can generate some code using some parameters, and put it into a function, a class, a struct, or a module somewhere, well, that's where we get the idea of a template mixin. Now, this might be a new idea for you depending on what programming language you're coming back from, so let's go ahead and take a look in the Deep Programming Language website on this feature, template mixins. So on the documentation, we're going to go ahead and look at the language reference, and if we scroll down just a little bit here, we'll see template mixins just below templates here. So again, similar idea where we're going to have some parameterized chunk of code that we'll be able to mix into our code. So again, combining these two powerful ideas. So again, if I make this just a little bit bigger, it says a template mixin takes an arbitrary set of declarations from the body of a template declaration and inserts them into the current context. So we have this syntax here where we're going to mix in some template here, and we can have any number of, well, we'll give it a name here, parameters, and we can also pass in constraints. For instance, if the parameters or whatever must be integer types or these types of things. So that's the idea. And then we can put basically anything within these brackets that we can mix in as regular D code. So same idea as a string mixin. So let's go ahead and take a look here. I'll keep this here, but let's do just a quick refresh here on this idea of templates or template blocks that we saw in a few lessons ago, where I can have a template, I'll just call it block, and I can parameterize it. And then anything within this block here, I can parameterize with the type t here. Or I could have, some value here like size equals 50 or something like that, that will go through a textual substitution. Now I'm just going to call this function called, get parameter here, and it will take in whatever the type is as the argument here, and it'll just return that argument here. So it takes in, based off of our type here of the block, the argument and just returns it. So a pretty useless function, but you get the idea that now we have this get parameter function here. So if I want to instantiate this block here, I have a block. Let's use it with an integer here. And then I could call get parameter, and it needs to match the type here for int, so 50 or something like that. And then I should be able to execute this. Okay, so it doesn't really do anything useful here. And along the way, we learned some tricks here where I might want to call this like my block of ints or something, or with a type here, and I could call just this first part here, just so I don't have the int that I have to specify in the exclamation. So again, there's nice ways or ways to make this look really nice here. Again, you have little shortcuts like typedef in other languages. In D, we use alias for that. Okay, so this is just a regular template block. So that first idea of the template mixin is that I'm just taking in the same, arbitrary set of declarations from the body of a template declaration, and then I can insert them into the current context. And that's where the mixin part comes here. Okay, so let's go ahead and make this a little bit more high-powered here and have this mixin here. Okay, so immediately, let's see if I add the keyword mixin, what happens here? Well, now if I try to compile this, again, it's not quite the same thing here. And in fact, we're getting a nice error message from the compiler saying mixin templates are not regular templates here. Okay, so that's not the idea here. So let's go ahead and use this feature appropriately. I'm just going to comment out this that we have here, and we could save it just for our records as an example usage here. Let's say example usage here. Nice to have some documentation. We have yet to talk about D's built-in documentation generator, but anyways, there's a little example here. What I really want to do here is with the mixin template to showcase this feature is let's go ahead and just make some struct here like this. I'm going to go ahead and add some fields here. Field 1, let's add another field 2 here, just to have something interesting. And this might be a use case where you want to use a template mixin. So the idea of my mixin is I might want to generate getter and setter functions for this struct here without having to type them out. Okay, so there's various ways you could do this, or you could say, hey, maybe I'll just explicitly type them out. But you might again want to have getter or setter functions. Maybe you want to have a function that you can automatically generate that serializes or deserializes this data. There's a whole bunch of different use cases we could probably think of. But let's just go ahead and go with this here. So I'm going to do here for the template mixin, which is preceded by the word mixin and then template as shown here. And then we need to give this a name here. I'm just going to call this getter. And then we can parameterize it with a type here. Okay, so we'll do this with some stages here. Now, what is the code that I want to mix in here? I mean, let's just go ahead and do an example function. I'm just going to call this return 42 here. We'll do something kind of similar here. And we'll just return the value 42. Now, this isn't making use of our parameter here in any way, but let's just go ahead and use this here. And what I'll do is just say mixin getter and then the type here. Okay, let's just say type of, this thing here. Okay, now let's see if this compiles here. Oops, it looks like I'm missing a my syntax here. I don't need the parentheses. Again, because this is a template, what do we use? Exclamation mark. There we go. After the template arguments. And this compiles. Okay, so what does it actually do here? Well, let's go ahead and create an instance of some struct called s here. And now I should be able to call s dot, well, what's the thing that's being mixed in here? It's this getter function here where I have return 42. So if I do return 42, effectively this code should have been pasted in right here. Okay, so that's the idea here. And let's do a quick write line here, just to make sure that this in fact returns 42, and we get it here, okay? So now all of our structures have this ability to call this member function here. So we can see where there's some of this interesting power now where we say, well, what if I parameterize this for different types here? Now I used a little trick here. I just used type of whatever this object is. Again, we don't want to forget some of these things that we learned earlier in the lessons if you've been watching these videos, but that's the basic idea. I could have easily just put in, you could have just written in some struct here if you want, but let's make this, a little bit more friendly code. Let's make the compiler work for us a little bit, but that's the basic idea. But let's make this do something a little bit interesting, more interesting. So I'll just comment this out here. And we'll use some of the metaprogramming stuff that we've learned about previously. We'll get more into metaprogramming as we go along throughout this series here. But what I actually want to do is mix in something that I can use a sort of string mixin within here and write a function that gets field 1 and field 2. So this is just kind of a nice little recipe here. Now, the first tip that I'm going to give you is within your mixin templates, what we usually want to do is our local imports. So I'm going to need traits here and for metaprogramming here. Okay, so these two ideas here. And the reason I want to have my local imports is because, again, remember what a mixin's doing. It's effectively copying and pasting that code. So I want it to be in the scope of this struct here. Because I don't know, for instance, if I'm going to have these imports elsewhere. So usually these imports are going to need to be found within your mixin. Okay. Okay, so now let's go ahead and write a little string function here. And I'm going to expose us here just a little bit here. Let's go to the documentation here. Let's go to our library and look at standard traits here, which allows us to extract information about types and symbols at compile time. And then also standard meta, which is allowing us to construct and manipulate template argument lists here. Okay, so what's in meta here? The main thing that we're going to need, and we're going to have a full video on this, is this alias sequence here. So go ahead and open up, just give you a preview of it. And basically all this is like a tuple. So it was known as a type tuple, I guess, in previous versions, but it's just a list of parameters here. Okay, so where might that be useful where I can get a list of parameters? Well, let's go back to traits here. Well, let's go ahead and see. And traits, again, which allows us to extract information about types is, the basic idea is I want to extract a list of, from this type, the fields here, field 1 and field 2. And if I can do that, then I can generate at compile time a getter function for each of these fields. Okay, so that's the basic idea here. So let's see if there's some interesting things that we have here. I think we have, what I'm looking for is like the fields. Okay, so that's going to give us the get a tuple of the types of the fields of some struct or class. And I need to do this at compile time. So again, I'm going to need to use this alias sequence thing here. So let's go ahead and just start with that here. Okay, so very first thing that I'm going to need to do, because I'm doing this at compile time, I'm just going to create an alias. I'm going to call this my field, let's do lowercase here, my field types equals alias seq, or sequence, that's from the meta library. And we want to get our fields from our type T here. Or I'm just going to use this trick type of this here. Okay? And maybe let's make this a little bit cleaner. I'm just going to say my type equals type of this. Okay? Just might clean up our code a little bit here. Fields of my type here. Okay, so kind of stare at this for a moment here. This is just going to be an alias for, well, some struct eventually. And my field type's goal is to just store in a tuple at compile time, field 1 and field 2. Okay, so now if I want to write a getter function for this, my goal is going to be at compile time to do a static for each. So this happens at compile time. That's one of the uses of static. I think actually you can get rid of this. I think D is smart enough with just the for each, but I put it in here. And basically I just want to iterate through my fields or my member variables here. Okay, so you know, that's the idea here. And I want to get the field names here. So my field name for each of the tuples. Let's go ahead back to traits here. Let's see, field name tuple here gets an expression tuple, the names of the fields of a struct, class, or union. Now, why do I want this? Is because I want to write or generate this code for like get field 1, get field 2. Okay, that's going to be the basic idea here. And again, this is going to be for my type here. Okay, so now I have a static for each loop. And now I can do my string mixin here, in which let's go ahead and expand this because it's going to get a little bit longer here. And I want to just mix in here based off of my field types here. That's going to be the return value, okay, of each of those that I'm iterating through. All right, I've got 2 of them here, field 1 and field 2, okay. And now, and I want that as a string, okay. So I'm going to take this property here, and then I'm going to concatenate and call get, and let's go ahead and say member, okay. Whatever this string is here, because I'm getting the field name tuples here, right? That's going to be the index of it and the member. So this is at index 0, index 1, and this is called field 1 and field 2. And then what else do I need here? It's just a getter function, so I'll have my parentheses, curly brace, and I'll just do return with a space because it has to be valid decode. And we want to return that member. And then a semicolon, close the curly brace. And I think that's it for that code here, and then just close the code for my mixin. Okay, let's go ahead and see if that works here. Oh, I got to get rid of the return 42 stuff that we have here. Let's get rid of that. And this works here. Okay, cool. And we'll go ahead and see what this previewed or made in a moment here. But that's the basic idea here. In fact, I don't even really need this to parameterize this, so we can make this even simpler here. I can just have this template mixin. I think I could just mix in the getter here. Let's see if that'll work. Oh, use of parameterized template. Maybe it just needs to be empty. Let's see if that works here. Oh, no, I guess I gotta have some type. Okay, that's fine. We'll just leave it as is here. That's a little trick here. We might want to do other things here. To make it a little bit more interesting. Oh, I see, okay. Let's just go ahead and leave the parameter in there, even though I'm not really doing anything interesting with it. But now the idea is that if I've done this mixin for these getter functions here, I should be able to, and let's make this a little bit bigger here and try to fit everything on one screen just so you can see what's going on. And this is something that always, I mean, this is some of the really cool stuff with D, I think, in my opinion, that you can do this type of programming here, is now I'm just going to call s.field1 equals, 47, s.field 2 equals, 56, and then let's just write line s.field get field 1. And then let's go ahead and do the same thing for field 2. Okay, so again, if you look at our struct here, we don't have member functions like we would normally have here, or methods as they're called in other languages. But we've generated at compile time using this mixin template a way to generate for each of these fields a getter function. Okay, so let's go ahead and run this here. Now, if we run it here, you'll see we get 47 and 56. Okay, so that's pretty cool. We're just mixing in this string here. And again, we can parameterize this. Sometimes what I do with these getters is I just put a like true false boolean here for if I actually want to run this code or not, because sometimes you don't want getters, sometimes you don't want setters. So again, you could put in a bunch of parameters here if you want. But that's the basic idea. Let's go ahead and run this. Whoops. Let me split my window here again. Let's run this code here with the mixed flag, just so we can see the actual code that was generated here. So I'm going to use DMD, the mixed flag, mixed code, and then I'll pass in my file here. Oops, let's see here. I think it's just mixin. Mixin. There we go. And again, that generates us the mixed code. So let's go ahead to the mixed code here. And we can see here's our mixin here. Expansion at main here at line from 31. And then here's the other expansion here. Okay, and we got, you can see the float. That was the return type, right? We got our field types here. The get portion here. The name of the member here, because that's a, this is a reasonable convention to have, get, and then the field name here, and then the return here. Okay, so that's the basic idea here. Now in D, we do have things like properties and so on. If you want to write or think about getters and setters and have them act as functions here. But hopefully that gives you an idea for this powerful feature for a mixin template here. This idea that you can parameterize and do things like, okay, getter, setter functions may be interesting, maybe not. Maybe properties are a better option. But again, you could have a mixin template that looks through all the fields and writes a serialization function that writes things out to a text file or something, right? And you can have all that in your structs without polluting your code, right? This is very elegant. This is just, a few lines of code here that we don't have to do too much with. Okay, so I think that's kind of cool. I think that's kind of neat. And perhaps one feature of template mixins here. And I'd be really curious to hear what your folks' thoughts are. If you've used this in other languages, if you're using this in D, what you're using it from, maybe we can gather some examples. I think it'll be really fun. So anyways, folks, with that said, I'll go ahead and end this lesson here. As always, you can follow and track your progress on courses.msha.io for the D language series. Hope you're having fun with it. And again, this is one of my videos I've been looking forward to making for a long time because I think it just shows off something really cool in the D programming language. I mean, we're just touching the surface of some of the trait stuff and the meta programming things that you can do. But again, really powerful things for you to generate code and in some ways write safer code by being able to generate some of this stuff and have a consistent API and so on. So anyways, lots of different interesting use cases, and I'll look forward to hearing yours. So thanks for your time and attention. I'll look forward to seeing you in the next one.